Hey folks, I was just taking a look at some thunderstorms that were developing in North Dakota this evening. Just taking a look at the overall situation. There's a upper level trough across the west with the southwest flow over the Dakotas, little spokes of energy moving across that area. At the surface we have an area of low pressure across western North Dakota with a boundary extending south from there. To the west of that boundary we have southwest to west winds at the surface, and to the east we have south to southeast winds at the surface. That's setting up a nice low-level convergence zone right across the west central Dakotas. And where you have air coming together at low levels, it gets forced upward. And if you're unstable enough, you get thunderstorms. And we are plenty unstable. Taking a look at the latest meso-analysis, your mean layer capes, mixed layer capes, are around 3,500. Those values are considered very strong, with DCAPE values 1,000 to 1,400 across this area. And high DCAPE values correspond to the potential for strong damaging wind gusts. Taking a look at the RAP model sounding for Bismarck, North Dakota, this red area here is your CAPE. It's your positive area on the sounding. It's a measure of instability. The CAPE values are 3,600, but that's very, very strong. So with a combination of low-level convergence and diurnal heating, if you can get your air parcel up to the level of free convection right here, that air parcel will ascend as it's warmer and moister than the environment around it. And as it ascends, it cools, condenses, and you get precipitation. We are getting thunderstorms developing across that area. And I wanted to show an interesting feature here. This is a classic three-body scatter spike. This is an artifact of the radar beam hitting hail in the storm. Hail is highly reflective. Part of the radar beam gets scattered down, hits the ground, bounces back up, hits the hail, and the radar paints that as this line that extends outward. It's whenever you see a three-body scatter spike like this, that means there's hail in the storm. And these high reflectivity values, these 70 to 75 dBZs, typically you're only going to get reflectivity values that high when you have hail in a storm. Taking a look at the three-dimensional view of the storm, that white area, that's 70 to 75 dBZs, that's all hail. That's a large area of hail in that storm. Your 60 to 65 dBZs extends over the minus 20 degrees Celsius line. This is a storm that will produce large hail and damaging winds. And waiting for the reports to come in. If they get a report with this cell,